So let's see how we can use this new skill to write a quadratic equation in completed square form. We're given this equation, x squared plus 8x plus 3. But what do we notice? The 3 is not the right constant to complete the square of x squared plus 8x. So we're going to subtract the 3 from both sides of the equation to get it out of the way. And now we have y minus 3 on the left is equal to x squared plus 8x. What do we need to complete the square? Well, let's remember our pattern. The pattern says we take half of 8, and that's 4. And then we square 4, and that's 16. So we need to add 16 to complete the square. Let's do that. We'll add 16 to both sides of the equation, and then we get y plus 13 is equal to x squared plus 8x plus 16. That's great. Now we can write the perfect square trinomial on the right as the square of a binomial. So let's do that. Y plus 13 is the completed square of x plus 4. Remember that we use half of the middle term in our binomial. Okay, so we still want to get it solved for y, and we have y plus 13 over here. So we'll subtract the 13 from both sides of the equation. We can't put that 13 into the squared term. We have to keep it on the outside. So we have y equals x plus 4, quantity squared, minus 13. So that tells us that that form of that quadratic is exactly the same as x squared plus 8x plus 3. Does that look familiar to you? It should. Let's do a verification. This time we're going to verify it in your graphing calculator. There's other ways to verify it, but we're just going to verify it this way so that you see that they make the same graph. Put one in as f1 of x and the other one in as f2 of x, or if you have an 83 or an 84, you put one in as y1 and the other one in as y2. And look at the graph and see what happens. You might have to change your window so that you can see all the way down to the full range of values of your vertex, and the graphs are the same, to tell that the graphs are the same. Okay, let's try something a little different. Given this example, we notice a couple things different. We have a lead coefficient of 2, but that's okay. We'll see how we handle that. First, we're going to notice that we have this minus 3, so we're going to move that over to the other side like we did before. So we get rid of it by adding 3 to both sides. But now we have this lead coefficient of 2, so we can't complete the square until we have that out of the way. So in order to get undo multiplication, we have to divide. So we're going to divide every term in the entire equation by 2. So what happens then? We'll just leave the left-hand side in fraction form, but the right-hand side simplifies to x squared plus 2x. Now what do we need to complete that square? Well, we take half of the linear term coefficient, and that gives us 1. We square 1, and that gives us 1. So we need plus 1 to complete the square. Let's do that. Let's add 1 to both sides. And then what we have is on the left, we have that expression, y over 2 plus 3 over 2 plus 1, and on the right we have our completed square, which is nice. So let's simplify the left side a little bit. We can combine this. 3 halves plus 1 is really 3 halves plus 2 halves. So that's 5 halves. And on the right we can write it as a perfect square binomial. Remember again that this is going to be half of this. Okay, so now we still need to solve for y. So let's multiply everything by 2 to get rid of our denominators on the left-hand side. If we multiply the left side of the equation by 2, we have to multiply the right side of the equation by 2. Okay, so let's not forget that. On the left side, the 2 distributes in. On the right side, we cannot distribute in because of our exponent. so be careful about that. But we can distribute on the left. So what happens when we do that? We just get y plus 5, and we still have the 2 in front on the right, and that's fine. But now we want to solve for y, so we subtract 5 from both sides, and our final equation is this. So let's recap and see what we have. Y equals 2 times x plus 1 squared minus 5 is the same as the quadratic and standard form of y equals 2x squared plus 4x minus 3. So what is the vertex of this particular parabola? It doesn't matter which graph you look at, but which one's easier to see the vertex? Well, remember, we have our vertex visible in that form. So what do we get? -1, -5 is the vertex. Let's verify this. How do we find the vertex in this form? Do you remember the formula we use? Okay, the formula we use for the vertex x coordinate is -b over 2a. -b is the opposite of this, the opposite of 4, and a is 2. So -b over 2a is -4 over 2 times 2, and that resolves to -1. Well, that's our x-coordinate. What do we do with that -1? We plug it into this equation for y to see what we get. What is y when x is -1? So let's do that. 2 times -1 squared plus 4 times -1 minus 3. And that simplifies because -1 squared is +1. And then we multiply, and then we subtract, and we get -5, exactly what we expected. So we see that -1, -5 checks, comes out as the vertex of the other equation as well. It will always do that if you complete the square correctly. Okay, so now try the others. I'm sure you can do it.